what is the natural and obvious symbol for momentum? I have actually seen a video, I've seen a number of videos where they've asked, where physicists have said to why the letter P. I actually did find one video which talked about why they use the letter P, but I can't remember what the answer is. So probably from the Latin or the Greek. And what is P equal to? All right. So we'll talk about a closed system and open system. In a closed system, whatever's interacting with each other, I'm taking it all into account. So if I took this marker and I drop it, the momentum increases, or at least the magnitude of the momentum increases. It starts at rest, it then falls, speeds up. So if I looked at just the marker itself, that's an open system because I'm not taking into account what's causing it to move. But if I take the marker and the earth both into account, it's now a closed system because I'm taking everything into account. Ignoring air resistance, of course. Kimberly, you had a question?
I had a question from the other chapters, but I don't know if to ask you right now or after class.
That will potentially just take a little detour here. Yes, what's the question from the other chapter?
For the graphs, like, you know how afterwards you had like a whole like 15 or 19 columns where it was like zero displacement and something
Right.
else. Were you talking about instantaneous displacement or?
If I don't specify displacement as overall displacement.
Because I was confused on that when I went to tutoring. He was telling me that he didn't really know how to help me because he didn't know if it was instantaneous displacement or just displacement.
If without any qualifiers, displacement is always overall displacement, velocity, acceleration are always instantaneous. Is that?
Yeah.
Okay. Yeah, that I think that was the day you actually came in late on the day where I hit that stuff.
Mm-hmm.
So hopefully that's enough.
Yeah, that's good.
Okay. Any other questions before we continue our romp through momentum? Then let's keep romping. All right, so a closed system, you're taking into account everything. Open system, you're ignoring what are called external forces, or the source of external forces, I should say. In a closed system, if you're taking everything into account, momentum is conserved. In an open system, well, in the case of the marker, momentum wasn't conserved with just the marker because it had no momentum, had zero momentum, and then it had momentum. So open system, momentum not conserved. And in this case, you would look at the impulse, that force times time is equal to the change of momentum. But we'll get back to that. Let's take a look at the closed system. That's the nicer one. I'm going to have an object here, traveling to the right. Let's make it 3 kilogram object. And it's heading towards another one, a 5 kilogram object, heading straight towards it. They will collide. Let's say this is going at 3 meters per second, and this is going at 4 meters per second. Ooh. I'm going to change that 3 to 6. I just want the numbers to be different. All right. So, what is the momentum of this object right here? I'm going to cleverly label this object 1 and object 2. You can email me later if you want to know how I came up with that stuff, but you know, inspiration. So for mass 1 here, what is its momentum?
It's 18, but what are the units for that?
How'd you get 18?
Mass times velocity.
All right, so the momentum of 1 and I'm gonna put a little I here for initial, this is before the collision, it's gonna be equal to the mass of one times the velocity of one initial. This is, now for most people, this is just alphabet soup thrown up on the board, but I felt the need to put it down anyway. So that's 3 kilograms times my velocity, which is 6 meters per second. And so you've got the 18. Now in terms of units, I got a kilogram times a meter per second, which cleverly is a kilogram meter per second. For whatever reason, they have decided not to come up with a single word unit for momentum. Or angular momentum. Now, this is, if you've seen the videos on momentum, I probably went into the Descartes. This is a chance to sort of make up your own unit if you want to, if you don't feel like writing kilogram meters per second. The shorthand is you can create your own. Please do not use any letter that is currently being used for something else. For instance, don't use capital N because your name is Nick and you want to go, oh, I want to honor myself by calling it the Nick. Capital N is being used for newtons, so please don't do that. So you can, perfectly acceptable if you write it down. I'm going to define one as a Descartes. This is just my own. I've had other students always write down kilogram meters per second. Other students do something off their letter. Some even use symbols without not even using letters. But I am going to define it. That's why I have the 3 lines there. Not just equal, it's equal because I'm saying it's equal to 1 kilogram meter per second. So this is valid just so long as that's there. If I erase the board starting in that corner, as soon as I erase that, this is no longer correct. On a quiz or test or something like that, you would just write it up at the top if you wanted to use something like that, or just stick with kilogram meters per second, which is also the same as 8 newtons second. So, you have some choices. Now, when Brittany told me the 18 in the whatever units, she did more, she set the answer for the second one. So what's the answer to the second one? What's the momentum of 2? Momentum of 2 initially. So close.
What did she say?
Say it again.
20 kilograms times meters per second.
Okay, that's not what I heard before, I apologize, that's right. 20 kilogram meters per second. There is a mistake here. Now, I'm gonna say the mistake is Lacey's because Brittany went first. If Lacey had gone first, then Brittany's wrong. What did Brittany establish when she gave her answer?
How she got the answer? How she got the answer?
No, that's pretty much set already before Brittany came along. Brittany did something that affected.
The units.
Nope, units are pretty much set before Brittany came into play. Hint, we're dealing with a vector here.
The direction?
What about the direction?
Oh, so it'd be negative.
When Brittany said that this was 18, she at that moment said that way is positive. It's not written down anywhere, so we need to establish that, so let's write it down. That way is positive. Why? Because Brittany said so. Now, Was that her intent? I don't know. But whether it was her intent or not, she did it. And so Lacey is correct in her correction. This velocity is negative 4 meters per second. This is the negative direction. So this is negative 20 kilogram meters per second. All right, questions up to there? Luis?
Okay, so for E2, so it's just normal 5 kilograms, or all we gotta do is just change the answer, so like in that case it's 20 to negative. It wouldn't be like -5 or -4.
Technically, to get this, it would be 5 the mass times the velocity of -4. So it's 5 times -4 officially.
Okay.
Does that address your?
Yeah, yeah.
All right. Now, some textbooks do this. I don't do this as much as I probably should. This is a capital P and this is a lowercase p. Unfortunately, they look pretty much alike. If you do something like that, the capital P represents the total momentum and the lowercase p represents the momentum of one object. But what I'm asking here is, what is the total momentum before the collision? So I'm just going to write a little top down there for total initially. Initial before the collision, final after the collision. So what is the total momentum before the collision?
Kilograms times meters per second.
Yes. Just as a side note, what you said is fine. Just my hearing is off. But you don't have to say times, you can just say kilogram meters, and it's implied multiplication. How'd you get -2?
Because I just added 18 kilograms meters per second or plus negative 20 kilograms.
Yeah. Can we just save a little time, just say units? We're dealing in kilogram meters per second, so unless you want the practice. So the total is just, you add them up. So P1 initial plus P2 initial. 18 plus -20, -2, and then tack the units on at the end. What is the total momentum after they collide? Oh, sorry, before we get to that, the Scott. Scott.
For these type of like problems, which probably will be on like other homework assignments, whatever. So we would be using like, I think his name is Hewitt. We would kind of be using those equations, but replacing them with momentum. Or is this just like?
I'm not quite sure I'm following the question.
Well, I mean, there's a problem like that, if I'm not mistaken, with the, his name is Hewitt, right? With
Yeah,
like-
Paul Hewitt. Hewitt's
Okay.
his last name.
Okay, so like, yeah, the Hewitt formulas or whatever, they look, that one thing that you did up there, it kind of looks similar, so I was curious, like, will we just replace the, whatever, like, those things are with momentum when it references, or that was.
So, all right, it depends on what I'm gonna do a scatter shot approach. I'm still not 100% sure what the question is. And I apologize for that, but, so the equation for momentum, P equals mv. I think Hewitt probably writes out mass times velocity, or he might simplify it more to mass times speed. But momentum is mass times velocity. I'm just using the shorthand instead of Hewitt generally writing the words out. There was another thing I was thinking of, and it's gone now. So on a quiz or test involving chapter 6, this is not part of Monday's test. I would write the way Hewitt wrote it, and then I would write it this way. But I feel like I've now completely gone off of what you were asking. You wanna try it one more time? All right, Brianna?
What I was gonna say might be what she's talking about. Are you talking about the force equals mass times acceleration?
No, because I mean, that's the definition, just like that's the definition, you know, those are all definitions. I mean, like, with the whole initial, like, obviously we're not talking about velocity, but like initial velocity plus, what is it? Something else velocity, like original and then like, okay, initial and like final velocity.
Right.
So, yeah, like something like that. Is that, it makes sense in my head.
Yeah, I mean, I have to somehow indicate before a collision and after a collision, then I just use I and F for initial and final.
But,
I sometimes use other things, but
okay, well, this isn't, don't worry about it. Sorry.
sorry, could you think of a different way of asking it? Trying to back out. Fine. Okay, sorry. Other questions? Okay, so it's a closed system. I have these two objects, not taking anything else into account. This universe exists with only these two objects. What is the total momentum after they collide?
Does it have to do with like conservation of momentum?
Yes.
Like half? Was it half? Okay.
No, not a half.
Okay.
But it definitely has something to do with conservation of momentum. Ooh, that's a loss of momentum.
Does it then collide or they not stop? Oh.
No, they would not stop.
If they collide, would object one be moving in a negative direction?
Yes, it would, I think we can safely say object one would definitely be bouncing backwards. But before we get to what happens when they hit, I'm asking what is the total momentum after the collision, and it has something to do with conservation. And the answer is simpler than you think, based upon the lack of response.
Oh, does that have to do with the total momentum answer?
Yes?
Okay, so once they collide, since we established a positive and negative direction, does that?
You're going far more complicated than you need to right now.
Okay.
Would they both usually go in negative 2 units in that direction?
Not, that depends what you mean by, they both be going, what do you mean by that?
Like their momentum?
They each have -2?
Yeah.
If they did each had -2, so after the collision, if each of them had -2 units of momentum, what would be the total momentum afterwards then? Which is,
Oh.
would be a Nobel Prize. I always find it interesting when they get the sort of blank stare on something like this. So let's think about what does conservation mean in physics? We did this last Wednesday, I believe. What does conservation mean in physics?
Having the least amount of change.
Say it again?
Having the least amount of change.
What is the least amount of change? It's a specific number here. What is the least amount of change that's possible? Right. In physics, something is conserved if there is absolutely no change at all. So therefore, it's a closed system, momentum is conserved. What's the total momentum after the collision? That's the change. What is the total?
-2.
Negative 2.
Yes. If that's the total beforehand, that's the total afterwards, regardless of what happens with them. Now, then we can get into specifics of what each of them are doing individually, but for right now, once I have established what the total is beforehand, I have what the total is afterwards.
So when you're colliding like that, it's always gonna be like the initial final.
Yes. Yeah. Especially on the board. Some of you might have felt something different happen on the activity from last Wednesday. Is there another question? All right. So afterwards, we'll start out with so this is before, after the collision. Is 1 kilogram mass shooting off to the left at, what does it say, oh, no, that was a 3 kilogram object. 3 kilogram object, mass 1, is shooting back to the left at 1 meter per second. The 5 kilogram mass has what velocity? Going back to F equals ma, if we were using F equals ma, Newton's laws directly, this would be a near impossible problem to solve. Because they exert no force on each other, then they touch, so now there's a normal force between them. They hit some maximum amount of force, and then they separate again. And so the force is not constant. The amount of time they're touching each other, but with momentum, all I care, if I know what's happening beforehand, I can predict what's going to happen afterwards. So that's what we're going to do. So P1 final. So the final momentum afterwards, that's all I'm asking for the first one. What is the momentum of the 3 kilogram mass after the collision?
Is that 1 meter per second and
Yes.
3 kilogram?
Yes.
3 units. Kilogram meter per second.
Negative
Instead of
3.
Yes.
So-
Negative. Negative.